like to walk you through creation of a network design for solving problems of timing and scheduling. This is the process we've gone through in class. I want to show it here in this YouTube video so that you have the ability to stop and change and look and analyze a little bit closer. First thing I want to do is I want to create what looks like a node. I'm going to use this as some sort of a template so that I have this consistency all the way through. I want to name the node, and I'm going to go get that node from the table, so just an equal, and I'm going to make this an absolute reference, which means I am going to push F4. The function F4 puts the $sign in front of the B and the 2. Now if your function F4 is not doing this, you're going to have to put the $signs in there manually. Now up here we're going to have the early start time. That is actually, as we're working through this network from left to right, the more difficult of the nodes to calculate. Now the early finish time is not. The early finish time is always equal to the early start time, which just go back 2 nodes, plus now I need to look up, so V lookup the node I'm in. I'm going to make that a relative address too. I'm going to make it a relative address so that when I copy this node, the function says, oh, go back 1 node, down 1 node, look up whatever's there. But the table is not a relative reference. It's always the same. It's never moving or changing. So I've highlighted the table and I have set it up as an absolute reference. The next part is to say, okay, in this table, where is the value that I want the function to return? Well, I don't need the A, I don't need site selection or none. What I need is this duration. So I'm going to put in a 4 saying that it is the 1, 2, 3, 4th column. And then I'm going to put in false because I need to have an exact match. I don't want Excel to just take its best guess. So for the early finish time, go back 2 spaces, look up the early start time, and then go to the table and look up the node and tell me what the duration is at that node for this node. So I should be able to push return. Notice the number 4 comes up, everything's okay. Now when we start working from right to left, we can actually put the late start time in right now. It's going to be equal to the late finish time minus the amount of time we spend at this node. Now we could use the VLOOKUP function again, but it's not really necessary because of the duration. The time we'll spend in the node is the difference between the early finish and early start time. Okay. So now I have a very good template, and I need 10 copies of it. So Control C, Control V, Control V, Control V. Now I need to get the node set, so I'm going to press F2. Then I'm going to drag this down to A, or from A to B. I'm going to push F2 on that A and drag it down to C, and then to D, and so on. A here really needs to be E. And then I need to finish these last 5 nodes. So F, G, H, whoops, I'm in the wrong spot, H, I, and finally J. I now need to construct the network. How do I construct the network? Well, the first thing I'm going to do is I'm going to take this node A and I'm going to just place it down here somewhere to give me a starting position. And then it says that B and C and D all follow A. So I'm going to move B, C, and D so that they all follow A. Next thing, E. Node E follows C. So I'm going to make it so that node E follows node C. Node C. I need node F to follow node B. And G follows E. H follows E and F. So H follows E and F. How am I going to do this? H follows E and F. I follows D. And J, the very last node, follows G, H, and I. So I need to position it over here. The next thing is just aesthetics. I'm going to go to the Insert menu, and I'm going to start putting in just lines. So I need to connect all of these lines. I'm using just Control V so that I can have quick access. Alright. F follows B. E follows C. H follows F, and E. G follows E. I follows D. And the remaining nodes all connect to J. So J has 3 predecessors. Okay. Next, the only hard coding we should ever have to do is this first one. I'm going to put a 0 there because we're going to start there at time 0. Here I have one edge going from A to B, so the early start time here is just the early finish time in A. Similarly, the early start time in C is the early finish time in A, and the early start time in D is the early finish time in A. Okay, once again I have a single edge going from B to F, so the early start time in F is just the early finish time in B. Single node here, or excuse me, single edge here. So I go and get the early finish time from C and place it in the early start time of E. Okay, first time we run into an issue is right here at node H. And in node H, I have 2 edges that feed into it. So I'm going to take the maximum of the 2 numbers that are on the left-hand side of the edges that feed into H. Okay. G, there's only a single node. I, there's only a single node feeding it. Excuse me, single edge. I keep saying node. And finally J, once again, there are 3 edges that feed into J. So I'm going to collect the early finish times from each of the 3 nodes whose edges connect to J. Okay, I've now passed through all the way from left to right. I know that this process is going to take 18 time periods. Well, the late start time, the late finish time and the early finish time are the same. So I'm just put equals the early finish time. And I'm now going to start working my way from right to left. Remember, the issues as we work from right to left are these late finish times. There is one edge connecting H and J. I'm going to go get the late start time and place it here for the late finish time. Same at node G. Same at node I. Going backwards, F. There's only a single edge connecting F to H. I am going to then get the late start time from H and place it in the late finish time for F. Now I have two edges coming back into E. So instead of the maximum, when I work from right to left, I use a minimum. I'm going to get the minimum of these two late start times. And the rest of it, with the exception of node A, should be relatively simple. There's just single edges going back between these two, between these nodes. So equals late start. And finally at A, I have three edges feeding back into A. Once again, I'm going to use the minimum. I'm going to use the minimum of the late start times from B, C, and D. Next step is to find the slack time at each of these nodes. We can find slack time in two separate ways. I can take the difference between the late finish and the early finish, and that will give me the slack time. I should be able to just take this node and copy it. So Control C. I'm going to copy it to every below every node here, all the way through this network. Same formula. It just says take the difference of the two numbers directly above. I'm looking for a critical path. The critical path is the path through the tree where there's no slack time. So the critical path would contain nodes A, B, F, H, and J. Every other node has some slack time. So there are, I could start process C at week 8, for example, rather than week 4. I have a little bit of time in here to spare, and I can still get myself done within the 18-day limit. So that completes our job. We've identified the nodes, the edges, early start, early finish, late start, late finish, and slack times, and then the critical path through the tree. Thank you.